Welcome to Tech Topics brought to you by Cybervenger. We help keep small businesses stay protected and compliant with cutting-edge cybersecurity and IT solutions.
Hello everyone, my name is Andy. I'm the Managing Consultant for Cybervenger. Today is another deep dive into the 110 controls of the NIST 800-171 standard. Today's control, if we look down here, is 3.5.10. And that just simply says store and transmit only cryptographically protected passwords. Okay, so a lot to unpack there. Very generic, but at least it's not one of those lawyered up kind of controls. Some of the controls in the NIST, it feels very wordy and very vague, political speak. They're trying too hard to be generic. This one is a good control because it makes sense to me. Anyway, I'll explain it. I think I'll be able to follow along. It's also good because it's a really important control. What it's telling you to do is very important for security. This is not security theater here. This is rubber meets the road kind of stuff. Okay, so cryptographically protected passwords. What that means is the password isn't stored as the password. So nowhere, let's start with an example. Let's say you have a database, an application, and that database, and you log in. When you log in as your user, you have the username and the password stored in the database, in a table. Here's name Bob, password, and it's stored in clear text. Very common. This happens all the time in older applications, and it's very, very bad for obvious reasons. If you can take a look at this SQL or do a select statement somehow, if you could trick the application into spitting out more data than it's supposed to, do like an SQL injection, maybe even just read only, and you could see what's there, it would show you the passwords in clear text. And then maybe that password is something you might recognize and go, oh, he uses password for his password. Let me try that other places, and then you can use that to go elsewhere. People have a habit of reusing their passwords. They get a password they like, and they use it everywhere, right? That's a problem, and this would be exacerbated by that. So what you would do in this case is you would have to store that password in some kind of hash that's not readable by anybody, but the program wouldn't be able to decrypt. It has to be stored encrypted. Now, you do the username too if you wanted, but certainly the password. Active Directory also has an option to store passwords in reversible format. You would have to not select that option. It's off by default, so by default it's secure enough to pass this particular control. But you would not enable that, and if you did, you would violate this control. So you want everything to be stored encrypted in hashes, especially if you're moving across the network. You don't want passwords going across. You couldn't use playing FTP. You'd have to use secure FTP. You couldn't use SMTP. You have to use secure with the TLS or something like that. And so this covers. It's a little redundant to the encrypt CUI in transit requirement. It's specifically passwords, but you wouldn't. This is more talks about encryption at rest of the password itself. Even if it's not CUI, the password, you don't want anybody getting a hold of that. That's sensitive information for obvious reasons, right? Now, a hash. For those who don't know what a hash is, a hash is basically call it a serial number that's computed based on the total contents of the thing. The thing might be a file, it might be a chunk of data, it might be a password in this case, it might be whatever. And the idea with a hash is when you change a teeny tiny little thing. Let's say it's let's say it's a password, and the password is "my duck is yellow." And if you change it from "my duck is yellow" and you capitalize the M in "my," the hash would go from 64-bit character to a completely different set of characters, same or similar length, by changing just one letter. The hash varies wildly with even just a tiny bit of change in the password itself. The idea is that the hash means nothing to you. So if you had a password that was blue, blue 2, blue 5, blue heaven, blue sky, the hashes would in no way be similar to each other of those passwords. So you can store those hashes easier. And then you can reuse those for session keys and things like that. There's other requirements about how those session keys must time out so they're not be used and prevent replay attacks and that kind of thing. That's a different requirement here. But the idea is that you at least have it hashed. You cannot see the plain text version of a password no matter what you do, so that the bad guy can never detect it and learn anything about it. Because people tend to use there's a lot of psychology, a ton of psychology involved in passwords. People use their pets' names, their children's birthdays, all kinds of stuff it's personal to them. And if you use a password once someplace, you use that kind of logic elsewhere, even if it's just logic. Like if you use a date on one, it might be another date somewhere else. So if someone finds out the password is 8/14/2007, and that person figures out, oh, your first child was born then, If that password doesn't work on the next thing they try, they might figure out, well, what about their other kid? Let's try that birthday. And then that might get them in because it belays certain type of thinking. That's why you never want anything in clear text. So that if they do compromise the password somehow and they can log in with the hash, at least it's a temporary thing and they don't have an idea what your password, thinking is, if that helps. So encryption at rest for passwords, it's kind of an obvious thing. And it's pretty straightforward. I hope that gives you a little more explanations what they mean by the cryptographically protected thing. It's really as simple as you might think. It's just don't leave passwords lying around in plain text. That's it for this one. I'm Andy. Thanks for watching.
Thanks for watching. We hope this video has provided valuable information to you. Be sure to share this video with other small business owners to spread the word about the importance of cybersecurity. As always, don't forget to like and subscribe for more videos like this. If you want more information about cybersecurity, visit us at www.cybervenger.com.